Hi, I'm Anna Kukleva, and this is joint work with Makarand Tapaswi and Ivan Laptev from Paris. Our paper jointly predicts social interactions and human relationships. Human relationships, such as friends, enemies, and colleagues, often consist of interactions. If you are friends, you spend time together in cafes, laughing at jokes, supporting each other, while enemies are likely to behave differently. Do you see the trend? Understanding human behavior is an important area with application to assistive robotics, social intelligence.
Your body temperature is still low.
Yeah,
How do we approach the problem of understanding human behavior? In this clip from Forrest Gump, we see that Forrest and Jenny are friends, and Jenny encourages Forrest to run away from the bullies. The interdependence between their interaction and relationship applies in both directions. Because they are friends, Jenny encourages Forrest to run. Or, because Jenny encourages Forrest to run, we can assume that they are actually friends. Note that interactions and relationships are directed from one person to another. The goal of our work is to answer who, what are they doing, and what is their relationship. Watching a movie entails seeing the action on screen and understanding the situation based on dialogue. We use multiple modalities to represent a video: the whole visual clip, character dialogue, and person-specific visual information. Interactions are short actions that happen in a few seconds to a minute. On the other hand, relationships are built over or last from several minutes to the entire movie. To model relationships, we average pull features from the same pair of characters from several clips over time. We now look at the multitask problem, predicting interactions and relationships together. We combine the two streams by concatenating the two representations and train the model jointly using max margin loss. We are also interested in predicting who is interacting. In this example, we want to see who is running away from whom and have relationship enemies. In particular, we study a weakly supervised setting where the model learns to detect the pair of characters involved using clip-level interaction and relationship labels. When we have clip-level labels, we treat the character pair as a latent variable and compute the score function with all possible track pairs. During training, we estimate the character pair that maximizes the score for ground truth interaction and relationship labels. For inference, we obtain a 3D tensor and maximize across all three dimensions to jointly predict the character pair, their interaction, and relationship. We also analyze how well our model can predict the third category given two pieces of information. For example, predict the character pair given interaction and relationship. We conduct experiments on the MovieGraphs dataset. We merge similar labels to obtain a total of 101 interactions and 15 relationships. How do modalities influence the performance? As many interactions are based on dialogue, the dialogue modality outperforms visual. Nevertheless, combining the two modalities and including person-specific visual features achieves highest performance. For example, in this clip, we see two ladies talking. Given visual frames, the model predicts common interactions such as asks or informs. Combining it with dialogue and character pair modalities allows the model to predict the correct interaction, reads. Our joint modeling of interactions and relationships shows an improvement over separate models. We observe that relationship-specific interactions, such as hugs, introduces, or runs, gain large improvement, while interactions shared by several relationships drop in performance. A similar trend is observed for relationships. We present results for predicting the third component given two pieces of information. The last column presents joint accuracy of estimating all three. While the task is very challenging, even in the fully supervised case, we are able to learn using quick clip-level labels without a significant performance drop. We show an example where our model jointly predicts character pair, interaction, and relationship correctly. To conclude, our work presents a new task and model to study the interplay of interactions and relationships. Our model efficiently encodes multimodal information. Joint prediction of interactions and relationships is particularly beneficial for some classes, and our approach for character pair localization performs well even when using clip-level interaction relationship labels. Thanks for watching our presentation.